Hi, all of you. So today we will study optical path length. So first of all, we will define this optical path length by two ways. Then we will derive a formula that will be very useful to guys to solve the numericals. So let's us define this optical path length. First of all, it can be defined as a distance traveled by light in vacuum in same time as it has traveled some distance in the medium. That means ki let there is a medium this and light is traveling through this medium. Let's suppose thickness of this medium is T. Refractive index is mu. So if light ray travel this medium, then time taken by light ray is equal to distance upon speed. Distance is T and speed of light in this medium is, we can write C by mu. This is equal to mu T by C. So in mu T by C time, light will pass through this medium. Now, in this time, in this time, the distance traveled by light in vacuum, where speed of light is c only. And this time, distance traveled by light in vacuum is called optical path length. So optical path length is speed in vacuum into time, this time. So c into mu t by c. So this is equal to mu t. So this is optical path length, mu into t, where mu is the effective index of medium and t is the thickness. So this is the formula. And if we define it by second way, we can write it represents the total distance that light would have traveled in a vacuum to cover same phase shift at as it does in the actual medium. So if light ray is traveling in a medium and let's say light ray travel from this point to this point, so we can write ki the phase change is equal to 2 pi by lambda into delta x displacement. So 2 pi by lambda of this medium, let's say this is lambda 1, into distance traveled, that is equal to t. Now we can write कि भाई ये तो medium का lambda है. Now we can write कि lambda of medium is equal to speed of medium upon frequency. Speed of medium is speed of in vacuum upon mu. Frequency will remain same. So lambda dash equal to lambda in vacuum upon mu. So 2 pi by lambda into mu. So if light ray travels through this medium, then this will be the phase change. Now, the definition written above is total distance the light would have traveled in a vacuum to cover the same phase shift. So if the light travels through this medium, this is the phase shift. Now, if this light is traveling through a medium, through vacuum, then what distance light should travel to get the same phase shift? So phi is equal to 2 pi by lambda, lambda of vacuum into distance that we don't know. So to get this equal phase shift, so we can compare. So x equal to mu t, and this mu t is optical path length. So we can define it by two ways, and this formula is mu into t. So how we will use this formula? This formula can be used key if a light ray is traveling through, let's say ki, there is a source S1 and there is a source S2, and this is a point P, and this distance is X and this distance is X. But this half, this lower half, is covered with refractive index mu. Let's suppose this is filled with some liquid of refractive index mu. And we have to find path difference at P, path difference. So we will write S2P minus S1P. Now I will write S2P as not X, but mu X. In optical, this is the optical path length. So if a light ray traveling in a medium of spectrum x mu, some distance x, so I will write that distance as mu x. And this is vacuum. So their mu is equal to 1. So this is simply written as x. So this is the optical path length. So use of this is key. If a light ray is traveling through a medium distance x of different x mu, then you will write that distance as mu x. So you can apply this formula and you will definitely able to solve the numericals. And if you have any doubt related to this, you can comment on the video. Either for more informative videos on physics, you can like, subscribe, and share my channel. Thanks for watching.